This is my lab report for lab 3 by Magee. So in the experiment, a magnetic meter measured the magnetic field produced by a bar magnet. In the first part of the experiment, the bar magnet was moved a distance from the magnetometer to produce a certain x component of the magnetic field, and a distance was measured. The purpose was to find n in the expression b bar is equal to k over r to the nth power, as the natural log of the average of both bx and r were calculated, then graphed to find the expression ln of the natural log of bx is equal to the natural log of k plus n times the natural log of r. In the second part of the experiment, the magnetometer was moved a horizontal distance d perp from the magnet, where the B net was 100 microteslas. Then the magnetometer was moved d perp vertically, and the components of the magnetic field were measured. While performing the experiment, it is necessary to understand how the magnetic north affects the measurements for the magnetic field due to the magnet. Also, during the coding, the equation B is equal to mu naught over 4 pi times 1 over r cubed times 3 times the dot product of mu times r hat minus mu was derived to calculate the magnetic field when treating the magnet as a dipole. So this was the setup in order to find where the magnetometer was. In both cases, in the first case, it was looking for when the x component was at its largest, while the y component was at its smallest. And in the second portion, it was looking for when the x component was at its smallest, while the y component was at its largest, in order to find the magnetic meter right here. And then this was the setup to find the magnetic field due to the magnet. So for the on-axis portion of the experiment, the average distance for R20 was found to be 0.316 meters, and the average magnetic field was 0.0204 times 10 to the negative fifth coulombs. For R70, the average Bx was 7.04 times 10 to the negative fifth teslas, and the average distance was 0.205 meters. In R120, the average x component of the magnetic field was 120 microteslas, and had a average distance of 0.167 meters. In R170, the x component, the average Bx was 170 microteslas and had an average distance of 0.15 meters. The equation for the natural log of Bx versus the natural log of r was negative 2.765 times 10 to the negative 13.97. This means for the equation b bar is equal to k over r to the nth power, n is equal to negative 2.765. In the off-axis field, the average d perp was 1.92, which made the average distance 0.271. The average magnetic field had an x component of 1.6 times 10 to the negative 6, 2.753 times 10 to the negative fifth, and negative 3.76 times 10 to the negative fifth, and the average magnitude of the B net was 4.664 times 10 to the negative fifth. And then this is the graph depicting natural log of Bx versus natural log of r, and the equation. So the following observations were made during the experiment. If the magnet was far from the magnetometer, then the x component of the magnet field read near zero, and as the magnetometer moved closer to the magnet, the x component of the magnetic field increased. So during the coding, the purpose in the code was to create a model that calculated the magnetic field for a particle that was 45 degrees from the magnet and a distance square root of 2 times d perp, then compare it to the magnetic field found on the x-axis part of the experiment, off-axis part of the experiment. In coding, the magnet was assumed to have a function of a dipole. And so this is the coding. The magenta arrow represents the magnetic field at a distance d 45 degrees away from the magnet. The white cylinder represents the magnet producing the magnetic fields. The orange arrows represent the magnetic field on axis. And the green arrows represent the magnetic field perpendicular to the axis. As stated, D was equal to 2.15, and B at 45 degrees at distance D was 9.45 times 10 to the negative 11th by 2.83 times 10 to the negative 10th power of Teslas. So, and then if the magnetic field had not been orientated to just the magnetic north, then both the x and the y components of the magnetic field would have been incorrect, and whatever angle was used would have changed how these two components would have changed with comparison to magnetic north. And if the two magnets were stuck end to end together, the magnetic field would have been twice as large.